Hey everybody, welcome to DirectX 11 tutorial 60. In this tutorial we are going to load in and display this Hello World sprite. It is going to be 256 by 256 pixels. First, let's go ahead and create a new header and CPP file for our sprite class. Let's go ahead and create the CPP file. And let's go up to Show All Files and move both of these up to the graphics folder. Down in the CPP file, we are going to include the header. And then let's just open up the header file. So we know that we will be inheriting from a 2D game object for our sprite class. So let's include GameObject2D, create this sprite class, and inherit. And this is going to be our prototypes. So first we have initialize. And initialize is going to take in the width of our sprite, the height of the sprite, the path to the sprite, the file path, the reference for the constant buffer for our 2D vertex shader, which we will get to this in just a second. For draw, we're just going to take in the ortho matrix, which will really be the camera's world matrix multiplied by the ortho matrix. We're going to have functions for getting the width and height of the sprite. We'll of course have to override update matrix. We're going to store a pointer to the constant buffer for the 2D vertex shader. We're going to have our world matrix and initialize it to XM matrix identity. We're going to have a unique pointer for our texture. And we're going to store a pointer to the device context. And we are also going to have an index buffer for the indices and a vertex buffer for the vertices. In the future, when we have some kind of resource manager set up, all of these sprites will probably just use the same indices and vertices, since we are just going to be drawing rectangles. Also, our vertex buffer is made up of vertex 2D, which we still need to create. So first, let's create the vertex 2D struct. Let's go into the vertex buffer. Or rather, we need to go into the vertex header. We're going to copy our current vertex. We are also going to, let's rename this to vertex 3D, since it is a 3D vertex. Alright, and we should get plenty of errors for changing that. So let's see. So we're going to do a Control H. We're going to replace anywhere that has vertex with vertex 3D. And do a replace all. Alright, let's see if this compiles now. Alright, so in model CPP, change this to be a vertex 3D. Alright, and I think that was it. So if we go ahead and make our 2D vertex structure, the only difference is we are not going to have a normal, and that is it. So we'll take out the normal parts of the constructor and the float 3 where we were storing the normal, and just change the name to 2D. Next, our sprite header had used a different constant buffer for the 2D vertex shader. So let's go up to our constant buffer types and just copy and paste what we had before. Is going to be for 2D. Now, all that we really need is the worldview projection matrix. So I'm going to take out the world matrix and just have the worldview projection matrix, because the world matrix was only actually being used for lighting calculations currently. Let's go back to our sprite header. And one other thing is I had forgot, we will need to pass in a pointer to the device context when we initialize. So I'll add that in. Now there are a couple more headers that we will have to add. We'll need the texture header to use the texture class, constant buffer for the constant buffers, string for the wide string, index buffer for the index buffer, vertex buffer for vertex buffer, and then vertex for the vertex 2D. Oh, one more thing is we will also need to pass in the device. Soon I'd like to cover implementing a pipeline manager so that we don't have to pass in the device and device context to everything, and it'll also help clean up a lot of the code. So let's take a look at the CPP for the implementation. Alright, so for our constructor, we're going to set the device context. We're going to set the pointer for our vertex shader's constant buffer, the 2D vertex shader. We're going to create our texture. We're going to pass in the sprite path, and for the texture type, we're just using diffuse. I just did this because this was, if we look at the texture constructor, it was set up where we have to pass in a texture type. It doesn't really matter for this case, because the only, thing that we care about is one texture for these 2D textures. Next, we're going to look at the vertex data. Now, if you remember from the last tutorial, I had said that our coordinates will work where the top left is 0 for the x, the right is 800 for the x, and for the y, it'll start at 0 and go down to 600, because that's our width and our height. So if we zoom in right here, now if we want to find the top left point, if we use negative 0.5, negative 0.5, we know it'll be up and to the left, because with this orthographic view, when we go up, our y-axis decreases, and when we go to the left, our x-axis decreases. So this will be negative 0.5, negative 0.5, and then for, I'll use dark red for the top right. So then we'll have the top right, and it will be 0.5, 0.5. And then we will have the bottom left, I'll use pink for that, which will be negative 0.5, 0.5, because it is to the left, negative 0.5, and it is down, positive 0.5. And now the bottom right, you may have already guessed it, we will use 0.5, 0.5. Now there is a reason that I used the number 0.5, 0.5. And that is because with this, the default width and length will be 1. All of these gray lines I just drew have a length of 1. So our texture will be 1 pixel by 1 pixel. So let's go back into the engine. This is just our index data, which, keep in mind, it just has to be in clockwise order. Then we initialize the vertices and indices, and we are setting the position and rotation to 0. Next, for drawing, we are going to take in the ortho matrix, or the view projection matrix from the 2D camera, and we're going to calculate the world view projection matrix by taking the world matrix for the sprite, multiplying it by the camera's view projection matrix. We're going to set the constant buffer for our 2D shader, which we still need to create. We're going to set the world view projection matrix and that constant buffer and apply it. Right here, we are just setting the shader resource to use the textures shader resource view that we created in the constructor. And lastly, we are just drawing this quad that our texture will be mapped to. If you remember, we had a get width and a get height, but up here in our vertices, we just have a 1 by 1 quad. So what we are going to do is we are actually going to add a new variable for the scale. So let's go to our game object header, and I'm just going to put it in here since it can apply to 3D objects as well. We're going to call that scale. We're going to create a function to set the scale. We're going to pass in the X scale, the Y scale, and then for the Z scale, we are going to default that to 1, since you should not be changing the Z scale on a 2D object. Now let's create that definition. All we are going to do is we're going to say scale.x equals x scale, scale.y equals y scale. There we go. Now we have a way to set the scale. So if we go back to our Sprite CPP, and we scroll down, right before we return true, we are going to do set scale we're going to set the width for the X scale, the height for the Y scale, and then we're not going to change the Z scale. So what we can do with this is down here, we can now have a get width and get height by returning the X and Y value of the scale. This is why I purposely made the vertices have a length of 1. So we know that our X scale will be our width and our Y scale will be our height. Now if we scroll back down, if we look at the update matrix, what we're going to do is we're first going to create a scaling matrix and pass in our X scale, Y scale, and Z scale, which really, it'd probably be better if we just pass in 1 for the Z scale, since we should never change the Z scale for a 2D object. Next, we are going to multiply that by the rotation matrix, and then we're going to multiply by the translation matrix. Now you'll see here that I didn't just pass in the X position and Y position, but I added the scale divided by 2 for the X and the Y. Now the reason that I did this is because if we go back to our initial example, let's suppose that we use a width of 1 and a height of 1, because we know that this is 1 and this is 1. Well, if we know that the position of this is 0, 0, right? It's centered at 0, 0. But if I set something at 0, 0, I want it to be at the top left, because that's how like widgets and stuff usually work as far as like UI layout. So what we are going to do is, if we add half the width and half the height, we will effectively move this down to the top left. So I know I dragged the border of this screen when I did that, but hopefully you understand what I'm saying there. So that is why I'm adding half the width and half the height right here for the translation matrix. Now we are almost through all of the boring stuff. So now we get to try to load this Hello World sprite. Let's go up to the graphics header. We're going to add a 2D camera. We need to add that include. And we also need to include Sprite. Sprite. Next, let's go to the graphics CPP. And let's go to where we are initializing the scene. All right. And right above our 2D camera, we'll do camera 2D dot set projection values. That's it. We'll pass in the window width, the window height. For the near Z, we'll do 0. For the far Z, 1. And we should be good to go for the 2D camera. We also need to initialize our sprite. Sprite.initialize device context. 256 by 256 is the width and height we want. For the path, it will be data textures sprite 256 by 256.png. And then we need to pass in the reference to the constant buffer for the vertex shader for the 2D vertex shader, which we still need to create. And then we will just return false if we fail to initialize the sprite. So that's right, we still need to create that 2D vertex shader and pixel shader, which luckily are really simple, and we need to add in this constant buffer. So let's go back to the graphics header. Go down to where our other constant buffers were. I got to come up with some better names for some of this stuff, but this will work for now. All right, so now we've created the 2D constant buffer. We still need to initialize it. So back in our graphics, if we scroll up, see this right here where we are initializing 2D, fail to initialize 2D constant buffer. Alright, so next we have to create the pixel shader for 2D and the vertex shader for 2D. Let's create a pixel shader 2D.hlsl and a vertex shader 2D.hlsl. So for the pixel shader, first remember right click, go to properties, make sure you have all configurations, all platforms selected, go to shader model 5 and choose pixel shader. Press OK. Our pixel shader is just going to take in a position and a texture coordinate. and it is going to sample that texture and return whatever color the pixel was that we got from that texture. So it's very simple. Now let's go to the 2D vertex shader. And for the 2D vertex shader, we're just going to have a constant buffer with our world view projection matrix. We're going to take in a float 3 for our position and a float 2 for our texture coordinate. We're going to return the float 4 for our position on the screen and the float 2 for the texture coordinate to sample. All that our shader is going to do is it's going to multiply the position by our worldview projection matrix, and then just assign the texture coordinate and return, and then it'll go to the pixel shader, of course. Next, we just need to also set up this shader to use 5.0 and to be a vertex shader. So if we go up to the graphics header, we will have to create a pixel shader 2D, and a vertex shader 2D. This tutorial's ended up being a bit longer than I expected, but I guess there just was a bit to add for this. So if we go to our graphics CPP, we need to initialize our new shaders. So first, this was the input layout for our 3D shaders. So let's change that to layout 3D. Let's put 3D here. Make sure we're not using the wrong variables when we do some of this. So this is for the 3D. We need to do it differently for the 2D. Because if you remember, the 2D only has position and texture coordinate. It doesn't have normals. So we're going to take that out. We use 2D. And then here, let's see, put 2D shaders, 3D shaders. So up here, we're going to use vertex shader 2D, pixel shader 2D for the name, vertex shader underscore 2D, pixel shader underscore 2D, and then layout 2D, number of elements 2D. So first, let's just make sure that this still runs. And then if it does, then we are going to add in drawing our 2D object, which it doesn't. So let's see, texture, no overloaded function, takes 2 arguments. All right. So in our Sprite CPP, I guess I forgot to pass in a device or something when I initialized a texture. Let's look. So I need to pass in the device as well. I didn't have this argument. So let's go back. We're just going to change this to device. All right, let's test this again. Oh, still failed. Can't convert from widestring to color. So what did I do here? Back to the texture header. Okay, maybe because I passed a widestring. Let's go back. Let's change Sprite initialize to just use normal strings instead of wide strings. And I believe that should address that issue. In my test code, I had changed a bunch of stuff and was using wide strings, so that's why that was there. But I forgot that. I'm still using normal strings in this, so. Let's test that again. Come on, please compile. Okay. So it compiled, and now we are ready to finally draw some 2D stuff. So what we're going to do is we're going to go up to our render frame, and after we draw our 3D object, so this is drawing the crisis guy. This is drawing that light. What we're going to do is we're going to do device context. We're going to set the pixel shader, get shader, and we're going to set the vertex shader. And then I think be ready to draw. We'll see. I keep putting this. I mentioned I wanted to get rid of all of the this spam inside of the code. It's kind of obnoxious. Alright, so we're going to do sprite.draw, and we're just going to call camera 2D dot get world matrix times get ortho matrix. And let's debug this. And if everything went right, we should see Sprite, but we don't. Okay, so I spent some time debugging and found out what was wrong. It was two things. First, the input layout. I wasn't updating it to the new input layout to be used by this 2D vertex shader. The other thing was when I added the set scale, this one's even more important, in the game object, when I added the set scale, after updating the scale, I wasn't calling update matrix. So with this not being correct, it would have just been a 1x1 texture and you probably wouldn't have even noticed it. So now when we go to test this, you will see we have our texture at the top left that says hello world. I know this tutorial took a bit longer than I had expected, so sorry about that. But now that we have this out of the way, we can look into something that's a lot more interesting, which is stencil buffering. You can do a lot of really cool effects with stencil buffering, so we'll get into that in the next tutorial. And as always, thanks for watching.